A tennis ball is thrown straight up with the initial speed of 22.5 meters per second. It is caught at the same distance above the ground. How high does the ball rise, and how long does the ball remain in the air? This problem is about free fall. Free fall is uniformly accelerated motion, and the acceleration of free fall equals 9.80 meters per second squared. The initial speed of the tennis ball is v initial 22.5 meters per second. How high does the ball rise? Let h stands for height. How long does the ball remain in the air? Let t stays for duration of the free fall. Let's make a picture. This is initial and final position of the ball. The ball is thrown at a speed v initial directed vertically. It rises, reaches the height h above the ground, and then returns to the same height. This process takes t seconds for the ball to return. Acceleration g is 9.80 and directed downward. So let's use the coordinate system directed the same direction as initial velocity, upward. The origin is at initial height, 0, x-axis. This coordinate is h. Let's consider 3 positions of the ball. The first position, starting position. The second position, at the point when its coordinate is h, and the final position 3. So, since this movement is uniformly accelerated movements, we can write 2 formulas for the component of displacement of the ball. The first, Sx equals v initial x t plus ax t squared over 2. The second formula is Sx equals v final x squared minus v initial x squared divided by 2 accelerations two accelerations, two components of accelerations. This is formula A, this is formula B. Now let's consider the displacement of the ball between the first and the second position. The displacement is a vector from starting point to final point. So S1, 2 vector. We know that here the speed of the ball is 0. So let's use the B formula. In this formula, Vx equals 0, final velocity. V initial x is V initial magnitude. And acceleration, component of the acceleration, since x is directed upward but g is directed downward, so ax equals minus g. And substitute these values into this formula. By the way, Sx, the main, Sx equals h. This S1, 2 like this. So we have, instead of x, Sx, we write h. Instead of Vx, we write 0. Instead of Vix, initial x, we write V initial squared. And instead of 2ax, we write minus 2g. And finally, we can write h equals V initial squared over 2g. This is the answer to the question, how high does the ball rise? The next, how long does the ball remain in the air? The starting point is 1, the second position is 2, the final position is 3. So the whole displacement from this point to this point, S1, 2, 3 equals 0. And now, since this formula contains t, let's use the formula A. Sx gives 0. The starting point and the final point are the same points. Ax gives minus g, so we can write 0 equals V initial t minus g t squared over 2. These two common factors should be taken out of brackets. 0 equals t times v initial minus gt over 2. There are two roots of this equation. 1, t equals 0. This factor 0. This is the moment of a start movement, for the starting point. And the second point 1. And these brackets is 0, v initial minus g t over 2 equals 0, ending point. Point 3. Let's use this formula. So you can see gt over 2 equals v initial. Hence, t equals twice initial speed over free fall acceleration. The answer to the second question. Let's calculate the results. H equals 22.5 squared meters squared over seconds squared times 2 times 9.80 meters per second squared. So second squared divides out, meters partly divides out, and we have a result in meters. Let's calculate 22.5 squared divided by 2 divided by 9.8 gives 25.82908 and so on. We must round this result to 3 significant digits. So we can write 25.8 meters. This is the height. How long does the ball remain in the air? Use this formula. T equals twice 22.5 meters per second over 9.8 meters per second squared. meters and meters divide out, seconds partly divide out, so result is in seconds. It equals 2 times 22.5 over 9.8 gives 4.59183 and so on. When you round to 3 significant digits, you should write 4.59 seconds. This is time, this is height. The problem is solved.